Hi, I'm Dr. David Tarditi. I'm the Vice President of Engineering at CertiK. Today, I'm going to talk about how Certicate is securing the Web3 world. Trustworthy blockchain systems are in demand. The world needs blockchain to be more secure. So if you look at blockchain, it has been seeing rapid growth. In 2021, blockchain contributed $66 billion to the global GDP. This contribution is predicted to increase by a factor of 25 over the next 10 years to $1.76 trillion. If you also look at the value locked in DeFi, it's increased by a factor of 23. As the usage of blockchain has increased, we've been seeing growing financial losses due to program errors. The program errors create vulnerabilities that attackers or hackers can take advantage of to steal money or objects of value. So in 2020, $516 million was lost this way. In 2021, this jumped to $1.8 billion lost due to program errors that created vulnerabilities that attackers or hackers were able to take advantage of. Here are the top blockchain attack categories. The number one attack category is attacks on cross-chain bridges. And these are attack categories in terms of monetary impact. Over $1 billion has been lost to attacks on cross-chain bridges. Cross-chain bridges allow you to connect one blockchain to another and move items of value across the blockchain. Now, the issue with this is that if there's an error on either side or an error in the logic that moves items across the blockchain, an attacker can take advantage of this. For example, there have been cases where attackers have forged or created malicious transactions. The second leading blockchain attack category are vulnerabilities themselves in smart contracts. So these are the programs that operate on the blockchain. They can include a variety of problems. These problems can create vulnerabilities that then can be taken advantage of by hackers. So for example, a common vulnerability is lack of input validation. So not checking that the input is correct. Another common vulnerability is the lack of access control. So access control is how you prevent somebody who doesn't have the right privileges from accessing a sensitive operation like minting or burning. So sometimes there are problems with these functions not being protected, which then leads to losses. The third category of attacks that are seen are what are called governance attacks. Governance is about the control and operation of a smart contract used by a project. So typically there are two ways that smart contracts are governed or administered. One is they're administered by the project itself that created the smart contract. Another one is they're administered through the community. So if an attacker can get hold of governance of a smart contract, they can change key parameters or change how the smart contract operates. For example, the smart contract may have a way of allowing emergency withdrawals in case something goes wrong with the contract. If a hacker gets hold of this, the hacker can use that emergency withdrawal feature to take money. There are more subtle problems that can occur, which is a hacker could manipulate the fees or pricing of items in the smart contract. So from what you can see, there are significant losses and problems occurring with blockchain due to security issues. It's really important that we improve the security of blockchain if we want people to adopt it widely. So I'll read this quote to you from Ray Dalio, an important American investor. Still, to one holding digital or cyber assets at a time when cyber offense is much more powerful than cyber defense, the cyber risk is a risk that I can't ignore. So there are giant challenges in securing safety critical software. If we look at our current environment where people are using personal computers, they're using Web 2 and they're using cloud, the security rate is less than 97%. Now, the things that people can do there, they can do monitoring of systems to make sure the systems are being used correctly. They can do proactive defense, which is once they notice something is going wrong with the system, you can take steps to stop it or halt it. The most common thing that people do is to patch vulnerabilities It's always a race between when a vulnerability is found and when it's patched. And then finally, people can rely on some amount of obscurity in the code. So you might not actually have the code for the operating system available if you're a hacker. You have to do what are called black box attacks. Now, if we look at blockchain and Web3 and contrast it to PCs and Web 2.0 and cloud, the first thing is that it's a new technical stack. So this alone introduces the possibility for issues just because the software is relatively new. The second thing to understand is that these blockchains are world computers that no one can stop. So a blockchain typically consists of a network of computers. The larger the network, the more secure the blockchain, but it means that you just can't stop or halt operations on a blockchain. So proactive defenses like what you do in the PC world or in the web world, it's not the same. Where you can, if you have to, in extreme cases, just disconnect your computer from the internet. Another issue with blockchain and Web3 is that smart contracts are hard to change. By default, on most systems, smart contracts are immutable. So on most blockchains, you really don't want the smart contract changing because people are depending on the behavior of that smart contract. So in contrast, when your PC has a bug, they go and patch the operating system. You can't really rely on patching the smart contracts. Two final last points about the differences. Most code on the blockchain and Web3 world is open source. That means attackers are able to read the code that the programmers wrote, and look for bugs in it. And this is different than in the PC and web world where maybe the source code isn't directly available. And finally, a single vulnerability in blockchain can lead to large losses. It can lead to more than $10 million lost. We've seen hundreds of millions of dollars lost. In contrast, in PC or the Web 2 or cloud world, typically the attacks are less costly. For example, if your PC gets compromised, the consequences, maybe you have to reinstall the OS on your PC. Maybe you lose some data for a couple of days. So we can contrast what's going on at the software level with what's going on at the hardware level. If you look at CPU hardware, the security rate is higher than 99%. CPU hardware relies on formal verification. Formal verification was introduced because, of course, if there's a bug in the hardware, once the hardware has been shipped, the only thing you can do is replace it, which is very costly. So if you look at CPU hardware, it took 22 years to discover the meltdown and Spectre vulnerabilities in CPUs. So, there are, in terms of the software side of things, the comment is that formal reasoning about concurrency in software seems to still be in the early stages. So if we look at reasoning about the complexities of software, we're still in the early stages of this, according to the NSF. Now, if you look at what we've done, what Certicay is about is we're combining cybersecurity with formal verification. And we're using this to secure blockchain and Web3 programs. So we're using the same kind of approaches that have been used to secure hardware in the past, or to verify that hardware works correctly. And so our security rate is higher than 99%. We've secured over $300 billion in crypto assets. We've served more than 3,200 clients. On average, we're doing about 250 audits a month. And if you look at projects involved in DeFi, you look at CoinMarketCap, for the ones that have third-party audit services, we have more than a 70% market share. It turns out that a lot of projects don't get third-party audit services. So overall, we have 12% of all CoinMarketCap listed projects under audit, 70% of those that actually engaged a third-party audit service. So how is CertiK creating the most powerful cyber defense for blockchain and Web3? Well, the first thing we have to look at is the team. So Certicate was founded by professors Rongwei Gu and Zhang Zhao. Professor Gu is a professor at Columbia University, and Professor Zhao is a professor at Yale and is the chair of the Yale Computer Science Department. Professors Gu and Zhao, in cooperation with Yale, founded Certicate. Professor Zhao is a well-established leader in the area of verifying and certifying software. He has more than 25 years of experience in that area. Professor Gu was the primary designer and developer of the verified concurrent OS kernel called CertiK. So CertiK itself is a big achievement. It is the world's first and only fully verified multi-core OS kernel and hypervisor. So in this case, the video that you're seeing there was CertiK deployed on the Landshark Robotics, an unmanned ground vehicle. It is a big accomplishment to have fully verified a multi-core OS kernel and hypervisor. Greg Morissette, Dean and Vice Provost of Cornell Tech, had this to say: 10 years ago, no one would predict that we could prove the correctness of a single-threaded kernel, much less a multi-core kernel. Zhang and his team have blazed a spectacular trail for the rest of us. So CertiK has been recognized in the research community. It won, work related to CertiK won Best Paper Awards in SOSP 2019 and OSDI 2021. These are leading conferences in the area of operating systems and systems software development. The related work has also won 3 Amazon Research Awards and was highlighted in the research highlights of the communications of the ACM. So in addition to having founders, both of whom are distinguished professors, we have an experienced leadership team at Certicay with decades of experience in the area. So Dr. Jason Cowell is our Chief Operating Officer. He has a PhD in electrical engineering and then more than 20 years of experience working across all aspects of businesses, including engineering, product development, and operations. Myself, I have a PhD from Carnegie Mellon. I spent 25 years at Microsoft before I joined Certicate as the VP of Engineering. I am an expert in compilers and programming languages, as well as operating systems and security. Dr. Wilhelm Solberg is a principal scientist at Certicay. He graduated from the University of Pennsylvania with a PhD in 2016. He worked with Professor Zhao as a research associate before joining Certicay. He is a distinguished researcher working on software verification, programming languages, and type systems. So in addition to having an experienced leadership team with deep technical backgrounds, our team itself has excellent educational backgrounds. So we have 180 engineers and 30 data scientists at Certicay. 18% of our employees have PhDs, 25% graduated from Ivy Leagues, and 41% went to top 10 CS schools in the United States. So how does Certicay secure blockchain and Web3? The idea that we have at Certicay is to have end-to-end security for the entire blockchain and Web3 lifecycle. So it consists of 3 things: auditing, which provides static protection, Skynet, which provides dynamic protection, and a leaderboard, which provides transparency to the community. So the idea is audits happen at the time that software is created before they're deployed to the blockchain. So we want to make sure the programs are free of vulnerabilities. After the programs are deployed to blockchains, we use Skynet to provide dynamic protection, to look for unusual transactions, to look for problems maybe that occurred, maybe there are new forms of attacks that might affect the software that's been deployed. And the leaderboard helps the community understand the overall security of the system. So as I mentioned, we've secured over $300 billion in digital assets. We've secured it across DeFi, across platforms, and across NFTs and metaverse systems. So how does Certicate defend against code vulnerabilities? We do a thorough manual review of the source code, and we use techniques like software model checking, which is a form of formal verification, static analysis, and machine learning to enable automated auditing. So the manual reviews will look for unusual problems with the design, or possibly new problems introduced by a novel blockchain product. The tools themselves will look for known problems. And so between the two, we can provide very thorough checking of the programs. And if people want to, in addition to the software model checking, we can also provide formal verification services where we go in and mathematically prove the correctness of the code. So in here, the diagram here shows what an audit result looks like for a report. So in this case, this is a sandbox. And so there were 6 findings here. One was major, one was medium, and one was minor. These indicate the severity of the findings. In other words, how vulnerable they are. A critical vulnerability is a bad thing. It means your program or your smart contract could get hacked very quickly. A minor one means maybe there's a limited amount of damage or a limited amount of value at risk, or it's very hard to do. And so in this particular case, the major vulnerability was mitigated, and then the medium and minor ones were resolved, meaning they were fixed. So here is an animation showing how the audit and verification process works. So first we review the code. Next we run tools. After running tools, then we take a look at all of what has been found, and we review the issues that have been found. So here, this is showing like the review page we might look at. So we can go line by line through the code and review all the issues that the tools found, as well as the issues that we found in our manual review of the code. And once we do that, we assess, are they real issues? Are there other things that we missed? And we then provide this information to the project under audit so they can fix these vulnerabilities that we've discovered. So as I mentioned, we complete 250 audits a month. We audit 5 million lines of code a month. We identify 3,000 vulnerabilities. Now, the thing about audit is that it's static. It happens once. The problem is, of course, what happens if a problem arises after the smart contract has been deployed? So for this, we have the Skynet system, which provides dynamic monitoring. So this monitors 2 things. It monitors transactions, so we can detect suspicious transactions and alert within seconds. We can also look for accounts that have a history of suspicious behavior or problematic behavior, and we can look for concentrations of assets that may indicate financial risk for a particular smart contract or DeFi system. We have had over 600 enterprise subscriptions to this since 2021. The second part of Skynet is monitoring the programs themselves, monitoring the projects and smart contracts. So this consists of both static analysis. We deploy and use our latest versions of our static analysis tools, as well as looking at social sentiment. So are there problems with governance? How responsive have people been to security issues? How quickly does the team respond? And so with Skynet, we can really get a sense of what is the ongoing security of the project. Now, one of the things about security is that it is hard for the average person or a business person, for example, to understand how secure a smart contract or blockchain system is. For this, we have a CertiK security leaderboard. This is available on the internet. And what happens is we actually assess the security of projects, give projects a security score, and then maintain a leaderboard on the web so that anybody can go and look and see what is the security rating of this project. And we have over 2,900 projects listed. If you want to see this, go to www.certik.com, and it's right there for you to take a look at. If you look at our clients for CertiK for blockchain and Web3, we have 65% of the top 200 coin market cap projects, 68% of the top 500 coin market cap projects that had audits, and 71.9% of all coin market cap listed projects that have had audits. Now, as I mentioned, there is a big opportunity for audits. So, there are some programs that really could benefit from audits. And if you see CertiK's quarterly growth, it's been over 1,200%. So finally, I'd like to say a word about our investors. We are supported by leading venture capitalists and leading firms in the area. So we've had investments from Sequoia, from Tiger Global. We've had investments from SoftBank. In the financial industry, Goldman Sachs has invested in us. Our investors also include leaders in blockchain and leaders in the blockchain space, such as Coinbase and Binance. So thank you for listening to my talk. If you want to learn more, I recommend you visit CertiK.com. We have videos, information, and lots of things you can look at and learn about there. Protect your community and organization today. Visit CertiK.com. If you want to get in touch with us, email us at bd@certik.com. Thank you.